Thank you. This book came out in 1951. I was 10 years old. It started my career, and I read it. I loved it. I was fascinated by weather. It tells you about fronts and storms, and I built weather instruments. I had a station in the backyard. I kept records, made observations, did forecasting, and decided I wanted to be a meteorologist when I grew up. And 7 years later, I went to Penn State and found there was another book that came out in 1951 called Compendium of Meteorology, which is 1,200 pages. It's a one-volume encyclopedia by leading authorities writing articles in the field. And it was a textbook and a reference book throughout my undergraduate days at Penn State. And those were very different times. And in the 1950s, when I went to Penn State in 1958, climate science was quite frankly a scientific backwater, a lot of developing weather statistics, not much of what you would call today the kind of climate science we have today. And many prominent scientists, including the person who wrote the climate change article for that compendium, were persuaded that human activities could not influence climate change for a variety of reasons, all of which we now know were wrong. But it's no surprise, because if you look back to 1958, we didn't have any CO2 observations. We didn't know it was increasing. The computing was truly primitive. They were vacuum tube computers. The first Earth satellite, Tyros, didn't get launched until 1961. And there was nothing that you could call in modern terms a supercomputer or a GCM until sometime in the mid-1960s. It was very early days, and the enabling technologies that have underlay the climate science we know simply didn't exist when I was an undergraduate. To put it in perspective, this was the ENIAC, the vacuum tube computer on which the first successful numerical weather prediction was made, that was published in 1950. That same calculation has, for fun, been reprogrammed for a cell phone recently. And that's the barotropic model. And the calculation, which took 24 hours of wall clock time on the ENIAC, took 1 second on the cell phone. So that's Moore's law writ large. Charles David Keeling started his famous observations in Mauna Loa in 1958. By the early 1960s, we had the first few years of the Keeling Curve. We knew that CO2 was increasing, and Keeling also established that it was due to human causes. So that's the initial empirical solid grounding for this subject. And I want to say a bit about the timeline here. So you can see these were the years I was an undergraduate and a graduate student in meteorology. And then after 5 years of postdocs at the usual places, I've spent my career at 3 places, NASA GIS in New York City, NCAR in Boulder, and UC San Diego. And one of the remarkable things about it is that in 1958, when I began, none of these 3 places existed. I mean, it don't mean that they got renamed. I mean, they didn't exist. NCAR was, and all of them were founded in the early 1960s. And in another sense, in 1958, there were only 14 universities giving a PhD in this field in the country. There are 5 times that many today. And that explosive exponential growth, driven by lots of things, including the Cold War, has in a way enabled careers for people of my generation. It created the jobs that we filled. And incidentally, when I was an undergraduate, there were no women classmates in the meteorology department, and there were no women professors. And that was true in graduate school, too. And if you look back, the number of prominent academic women in atmospheric science was tiny. You could enumerate them on the fingers of one hand. So this was an all-male field. True of many sciences, certainly true of this field then. I didn't switch to climate from numerical weather prediction and geophysical fluid dynamics until I went to Scripps at UCSD in the late 70s. I want to now switch gears for a moment and ask you to entertain me in a thought experiment here. Call our planet, the one we actually live on, Planet A, in which human-caused climate change is going on, and we have a well-developed science to help us understand it. And think about the possibility, the very real possibility, that the science hadn't developed. In a way, it's a kind of coincidence, I think, that at the very time when human-caused climate change was becoming real and serious, this science developed. You could easily imagine a world in which we still had fossil fuel as an energy base. Climate change was happening, but we didn't happen to have invented yet the satellites, the supercomputers, the technology that underlies the science. And then call that planet, the imaginary one, Planet B. Climate would be changing, people wouldn't be sure about it, we wouldn't have the tools to monitor it, and we certainly wouldn't be able to understand and predict it, so it would be controversial. And I think the discussion of it would very likely be on non-scientific terms. And as you know, there are a lot of people who are effectively living on planet B. These are our friends who, who either don't know about or refuse to accept the science, the sort of facts and evidence approach to learning things that everybody in this room would agree with. And I think these 4 features here would be typical of our friends on planet B. They would think of climate change as some threat for the distant future, hypothetically. They didn't realize it was here and now. They couldn't accept that it was human-caused. That was the fact in the compendium article, for example. They didn't have any clue as to the seriousness of it, and they would be violently opposed to certain policies, like carbon taxes. And of course, in our country, the Planet B folks are in charge of one of the national political parties, and we all know people who live on Planet B. And on a brighter note, I'll come back to that, but on a brighter note, I was, as John said, part of the beginnings of AGCI, and I came here for many summers. And this 1994 session that Catherine Gauthier, a longtime collaborator of mine, have co-chaired, produced a report that was very influential. The Department of Energy, for example, reproduced the AGCI report word for word under DOE covers. It was a part of their flagship climate change program, the Atmospheric Radiation Measurement, or ARM program. It was, gave rise to lots of good things. And it was largely written and edited by a quiet woman who sat in the back of the room at AGCI in those days and took notes. That was Susan Hassel. And so I got to know Susan then, and we started working together the next year after working on this report, and are still working together today. So there are actually women in this field now. Catherine Gauthier is certainly one of them. Susan's another. I'm going to mention 2 more. Susan edited the first edition of my popular book, which we did in '95. It was published in '96. And there are a number of other women. I want to mention 2 others. Susan, by the way, and I are still working together. She's going to talk more about some of this. We give workshops to help scientists communicate better. But Sherilyn Morrow, who is here, is somebody else whom I had known before AGCI got started. I met Sherilyn when she was a grad student in the 1980s. I've known Catherine Gauthier, who's French, since she was a grad student in the 1970s. And at AGCI, I met Lynn Russell, who was at Princeton then, is at UCSD now, who's been my research partner for the last 10 years. So John, I want to thank you and AGCI. By the way, happy birthday to Sherilyn. It's her birthday today. So for somebody who was educated in a female-free environment, I have been a joyful beneficiary. That's Katrine and Sherilyn on the top, and Susan and Lynn Russell on the bottom. So it's been a great pleasure, and I've worked with other women, and lots of my collaborators have been men, but these 4 I associate with AGCI. I want to finish up by talking a little bit about future topics for AGCI, which is one of our assigned chores here. And I think that this year's headline climate science event so far has been the announcement by Eric Rignot and others that the inevitable collapse of parts of the Western Arctic ice sheet has now started, and there's no way to stop it. There's a mechanism that's well understood. These are ice sheets that are grounded below sea level on a sea bottom that is sloping downward towards the continent, and it's a tipping point that had been identified in the 1970s. We now seem to have passed it. And the portion of the West Antarctic ice sheet, the Amundsen Sea portion, carries a meter of global sea level rise, likely will trigger the collapse of the rest of the West Antarctic ice sheet, which is 3 to 5 meters, which will play out over coming centuries. The time scale is uncertain. But I think it raises a number of issues that would be good for IPCC, for AGCI to talk about. One is to look more deeply into the well-known shortcoming. Every single one of the 5 IPCC assessment reports has given sea level rise projections that are too low, as shown by subsequent data. I've written about that, many other people have. IPCC had made a decision at AR4 and kept to it in AR5 to reject so-called semi-empirical or statistical models in favor of process-oriented models. I think the emphasis on projecting for 2100 in a field where we can't set a timeline precisely and neglecting the area, the long-term asymptotic effects is a mistake. And I think it raises issues in the science studies field. There's been a number of papers out looking at the issue of whether scientists and the IPCC process are inherently conservative and prefer to err on the side of least drama, as they say, to minimize the possible high end. I think these are topics that need attention. And among the sessions I'd like to think about and the solutions rather than the science side, I think this is a tongue-in-cheek way of saying I think that we've got a lot of work to do in media coverage. The media did a very bad job of covering AR5. It was ignored by the US mainstream media largely. And I think that the announcement by the CI specialists got a day's coverage that has been forgotten. So there's a lot to be done there. The two projects that I've listed here, the two topics that I've given a lot of thought to, you often hear the comment that it would be useful if we accelerated climate science and related areas by having a Manhattan Project approach. And I've come to the conclusion that modeling it on the Marshall Plan might be better. I'm going to say a word or two about that and then talk about trusted messengers, and then I'll close up. Still good. Still good. Great. This was the key sea level graph from the National Climate Assessment. I like it. It's written in feet for American audiences, but you see for 2100, there's a range of process model sea level rise depending on emission scenarios and so on, from much less than a meter to a little more than a meter. But then there's a second range here, and in very careful language, the National Climate Assessment says that you might consider, if you're interested in potential risks, you might consider this larger range going up to 2 meters or so, which comes from the semi-empirical models that the IPCC has decided are too unreliable to be considered. I think this bears careful study, and I like the way the National Climate Assessment came down on it, and I think it's a topic that would usefully be the subject of an AGCI session. The Marshall Plan, I actually found this poster which was from that time, a windmill with the flags of the European countries. For those of you who don't know the details, after World War II, when Western Europe was devastated and the economies of all the countries were in ruins, the US initiated a bipartisan effort. Truman, a Democrat, was president. Congress was controlled by Republicans, to rebuild, help Europe rebuild. It didn't rebuild it, but it certainly helped, on the grounds that essentially a strong Europe that would become allies and would become trading partners needed help in rebuilding, and it was successful. By the end in 1952, the European economies were all above their pre-war levels. And the amount of money, curiously enough, if you translate this into modern terms, it was a total of 10% of GDP, or about 2% per year, which is the kind of number we were talking about yesterday afternoon. And this was received large popular support. The Western European countries loved it, and by every conventional measure, it was very successful. And I think this is the prototype or the paradigm that we might think about, as opposed to a technology-driven engineering project like the Manhattan Project. I think this is much more apt and much more potentially productive. And I think AGCI might be a wonderful place to discuss it, because it will require a large number of perspectives. In 2 minutes. I wanted to close on an upbeat note. It's commonplace for communications people to say that the key to effective communication is simple, clear messages repeated often from a variety of trusted messengers. We didn't invent that. Susan and I say it all the time, but so do many others. And 2 years ago, I had the great privilege of spending a morning in a public conversation with my colleague Virabhadran Ramanathan and the Dalai Lama in a big auditorium at UC San Diego, with thousands of people present and many more hooked in, and it's online. You can get the whole conversation. The Dalai Lama turns out to be a very sharp cookie. We spent some private time with him too. He's funny, he's knowledgeable, he's witty, and you don't have to be a Tibetan Buddhist to understand that this man is revered and respected worldwide. And I think he is a primary example of a trusted messenger. He knows about climate change, he gets it, he does talk about it. And I think that what hasn't happened yet in climate change is we haven't found either the religious and spiritual leaders or the secular leaders of the caliber of Mahatma Gandhi and Nelson Mandela who will carry this message effectively to a whole global population and will phrase climate change and frame it in terms of the ethical and moral issue that it really is. And I think, again, this task of identifying trusted messengers and all the allied paraphernalia that come with that, it would be a very nice AGCI topic. Thank you very much.
you say a little more about your Marshall Plan analogy? Like how does that, I mean, how would that work in a climate change context?
I think that I've gone to a lot of the COP meetings, the conferences of the parties to the Framework Convention, and I think they are focused entirely on emissions reductions targets. And as we all know, they've been unproductive in the sense that there are no agreed upon international binding commitments. But I think they neglect the kind of things that have worked well in analogous situations in the past. So if you look back, for example, to the ozone agreements, then it was not simply a question of phasing out CFCs. Money changed hands, technology changed hands, developing countries got longer timelines than developed countries, and so there was an exchange that was mutually beneficial. And in the end, as you know, it was successful. We have phased out CFCs and allied particles. Although that was a very depressing issue at the time. You know, Sherry Rowland, who was a great hero of that issue, his famous story, came downstairs one morning and his wife asked him, Joan said to Sherry, "How's the work going?" This was he was finishing up the calculations with Mario Molina, that for which they later shared the Nobel Prize. And Sherry Rowland famously said to his wife, "The work is going very well. The world is in trouble." And I think if you have to think back to that time as to how pessimistic it seemed to essentially be able to save the ozone layer, but it has happened and it's healing now.
Yeah. So I think your summary of the Marshall Plan and the attractiveness of that is exactly right. And this may actually be a really interesting topic for us to look at AGCI. What would a serious program look like? How would it emerge? We ran a session in 1995, I think, with Tom Schelling, and he gave a talk about using the Marshall Plan as a model. Abe Shays was a lawyer since deceased at Harvard Law School, Gene Skolnikoff, and myself. And it might be interesting to kind of revisit that. Given what we know, what are the shocks that are likely to bring this into effect? It's interesting that the Marshall Plan didn't begin until 47, 48, right, which is actually long after it was needed, but it required that amount of time to see that Europe was sliding into an abyss and into the Soviet Empire before people were willing to spend what became several percent of GDP or 10%.
Right, right. No, thanks. I agree.
Just a quick comment. One of the things, so I recently chaired AGU for 3 years. I was chair of AGU for 3 years, and one of the things I really wanted to bring in as a frontier speaker, maybe this is something that AGCI could think about, I wanted to bring in a prominent Republican to talk about what happened to the environment on the Republican agenda. You know, because when you think back on it, EPA was started by the Republican Party, and it was really, there was a disengagement of the climate as a science and climate as a religion, you know, just prior to the Bush administration. And Kyoto, of course, just steamrolled. So the idea of a Marshall Plan or that kind of a structure to solve a big problem is a good way to frame it. But what you really need to do is that trusted messenger that you were talking about. And we were never able to get, we wanted to get Arnold, we wanted to get Colin Powell. We couldn't afford their, you know, Arnold wanted a private jet from LA. He wouldn't take commercial. I mean, there were issues with getting some of these people out of the but there might be an opportunity somehow to think about how do you engage that party to think about the environment again. You know, that was something that we really worked hard at.
Well, Aspen has a monopoly on private jets.
Richard, the question is that both of those analogs or examples that you gave was based on the premise that there was an acceptance of both conditions.
Yes.
And at the moment, the null hypothesis that we use in our work is that exactly the opposite of that. So should we fundamentally change our approach to the science and therefore the communication plan associated with it to set the stage to promote the Marshall Plan-like thinking and philosophy, because it really does require fundamental change in the current way of thinking, both within the science community as well as in communication, our communication with the public. So
I think you're right. I think that's a topic for discussion, but I think we do have these examples, and I mentioned Mandela, I mentioned Gandhi, I could have mentioned Martin Luther King, there are quite a few others. These are people who have played key roles in bringing about real change. And they have mobilized the popular opinion that, as you recognize, is absolutely necessary for any of these political activities to succeed. Today we're living in a world where we've got a lot of promising technology and a lack of political will. And so I think it's perfectly appropriate for us to focus on that.